And this third problem here, just like the calorimetry lab that we found the specific heat of an unknown metal, or calculated it for known metals, we're going to do the same exact thing here. We got a piece of an unknown metal with a mass of 14.9 grams. We heat it to 100 degrees Celsius and we drop it into 75 grams of water, and that's at 20 degrees Celsius. The final temperature of the water is 28.5 degrees Celsius, and we want to find out the specific heat of the metal in joules per gram degrees Celsius. I need a question mark there. There we go. So here the trick is that a lot of people get fooled where this says the final temperature of the water is 28.5 degrees Celsius. Well, this is not only the final temperature of the water, this is also the final temperature of the metal. If the metal were still warmer than the water, well, it would stand to reason that the water would also get warmer. Also, if the water were colder than the, if the metal was colder than the water would get colder itself. So this 28.5 degrees is going to be our final temperature of both the water and the metal. So what does this problem give us? Well, we've got a mass of our metal, so I will call that MM, or M1 if we wanted to, of 14.9 grams. And we're going to heat it to this initial temperature. So my temperature initial, we'll call that Ti of our metal, is 100 degrees Celsius. And we're going to drop this into 75 grams of water. So this looks like our mass of our water is 75.0 grams. And the initial temperature of this water, TIW, is 20.0 degrees Celsius. And then our final temperature of the water, it says, is going to be 28.5 degrees. So temperature final of our water, 28.5 degrees Celsius. Well, as we just said earlier, that's also going to be the temperature that's that our metal is going to be at the end of this, and that'll be 28.5 degrees Celsius. And we're looking for our specific heat of our metal, so we're looking for C of our M. We don't know what that is. Since this is going to be in joules per gram degrees Celsius, we do know our specific heat of our water. We have two options. We can do it in calories per gram degrees Celsius, which of course is 1 calorie per gram degrees Celsius. Or we can do 4.18 joules per gram degrees Celsius. And it stands that this answer is we want it in joules per gram degrees Celsius, so we'll use that as our units for our specific heat. So we'll do 4.18. I think when I did my numbers, I did 4.184, took it one place further. But if you just kept it at 4.18, you'll get a similar answer. That's going to be joules per gram degree Celsius. So we're going to use the equation C1, or I'm sorry, M1 C1 delta T1 is equal to negative M2 C2 delta T2. The ones are just going to be my metals, and the twos are going to be my waters, and if I switched them, it wouldn't make a difference. So to get our delta T, we're just going to subtract final minus initial. And since our metal's going down in temperature, we're just going to end up at negative 71.5 degrees Celsius. And for my water, it's going up by 8.5 degrees Celsius, so my delta T for the water is 8.5 degrees Celsius. Now I'm ready to plug all this in. 14.9. Actually, you know what I'll do is let me solve this for C1. So to get that all by itself, I'm just going to divide both sides by M1 and T1. So this is going to give us negative M2 C2 delta T2 over M1 delta T1. If you plug the numbers in first, it will give you the same answer. So I'm going to pause this because I'm running out of time, plug in my numbers just to save a little time. So we plugged in our numbers. Now we're ready to do the math, plugging in our calculator these numbers. Notice our negatives are going to cancel, so we'll end up with a positive specific heat, and we end up with 2.50 joules per gram degree Celsius. If you end up with a negative specific heat, something went wrong. Basically what that would mean is that as you added heat to something, its temperature went down, which is kind of doesn't make sense. So if you ended up with a negative, you either forgot this negative or made your change in temperature of the metal positive. So that's how you do number 3.